and fogging off. And
Lesson 1.6. We are graphical transformations. Okay, that's the official title of this lesson. Transformations. Okay, we did this in Algebra 2. In Algebra 2, you had a list that kind of had all of these pieces on it. Okay, this year I kind of expect you to know a little bit more, but we're going to go through, talk about them, and then we're going to, use these. So, the easiest ones, horizontal and vertical translations. Okay, these all fall under the umbrella of transformations. Translations are when we're taking a graph, a point, and doing what with it? No.
Moving it down a strand.
Moving it up, down, left, right, So for horizontal translations, that's when the number that you're moving it is in the parentheses, in the absolute values, under the radical. It is there with the x. And when it's there with the x, this is what you have to watch out for. Notice, when it says minus c, what are we doing? Right c. When it says plus c, we're going left c. And so if you had me last year, this is where I would always say, when you go left or right, or when it's in parentheses, or in the radical, or in the absolute value, you're going left or right, opposite the sign. So if you had me last year, that definitely sounds familiar to you, right? So left or right, opposite the sign.
Why can't they just say...
Now, over here,
That's not how math works.
when the number is added or subtracted at the end. So it's away from the x. In other words, it's not in the parentheses with the x. It's not under the radical. It's not in the absolute value. Whatever the case is, if it's a plus c, it's going to tell me to go up c. If it's minus c, we're going to go down those units. So when it's added or subtracted at the end, it's up or down, and you go with the direction of the sign, yes? So it makes sense in that positive is up and negative is down. Reflections, okay? 2 of these are old news. 1 of these is new news, okay? So reflection. If it's a reflection across the x-axis, so x-axis being the horizontal axis, so that means it's going to flip up and down, then it's negative f of x. And that is where you just take the function and you multiply everything by a negative. So if every term has an opposite sign, it's reflection across the x-axis. F of negative x is reflection across the y-axis. And that's when you just put in a negative x every place you see an x. So some of my terms will be opposite, some of them won't. It just depends on what you're doing there. And then when you combine the two, okay, when you flip across the x-axis and across the y-axis, or in other words, you're reflecting through the origin, that's negative f of negative x. What did we talk about lately? If something is odd, that's where we talked about it, right? If something's even and symmetric across the y-axis, so it reflects there. If something's odd, it's symmetric across the origin, so it reflects through the origin. And remember, I always said that's basically doing an x-axis reflection and then a y-axis reflection, right? Well, there's your proof, negative f of negative x. It's combining those two pieces. And then these notes say stretches and shrinks. We didn't necessarily use the word shrink in Algebra 2. I think the Algebra 2 book used compressions.
No, I didn't do this. Well, I did. The only thing that I remember last year from this thing, it was one of my first ones, was the horizontal translation and the vertical translation.
Okay. And those are the ones we use the most. We use the horizontal and vertical the most, but so stretches and shrinks, or if you prefer, stretches and compressions. I'm not picky about whether you use the word shrink or compression. The same thing. It depends on the book, it depends on the curriculum as to which vocabulary words you see there. Now, I'm going to jump down to the bottom one for a moment. This is the one you're probably most familiar with, because this is the one we focus on in Algebra 2, where if it's c times f of x, I think in our Algebra 2 book it says a times f of x. But it's the idea when you have a value multiplied, these represent your vertical stretches and compressions. And that's what we worked with last year, mostly. was the vertical. Whoops. Vertical stretches and compressions. And the key is, if the number you're multiplying by is bigger than 1, then it is a stretch. If the number you're multiplying by is less than 1, now still positive, okay, we're always talking positive numbers, so basically when it says less than 1 here, you could think of it being a number between 0 and 1. I think that's maybe what it said in our Algebra 2 notes. But if it's a number between 0 and 1, it's a vertical shrink. And this is if the number is multiplied out front. Okay? Now, to go along with that, we're also going to talk about horizontal stretches and shrinks. And so this right here is our horizontal stretch and shrink. And you'll notice instead of the value being multiplied out front of the function, it's dividing the x value. Okay, so horizontal are the ones that are a little bit trickier. It's dividing the x value. It still has the same rules, though, that it's a stretch if the value is greater than 1. It's a shrink if the value is less than 1, or in other words, between 0 and 1, if you will. Okay? Now, we will look, when we get to this section, which I think is on the back side, we'll look at the connection between the vertical stretch and shrink and the horizontal stretch and shrink. Because there is definitely a connection in that, let's see, if I am shrinking something vertically, what's that doing? It's compressing it down, yes? What happens as you compress something down? It gets wider. And so that's going to be equivalent to a horizontal stretch. Okay? On the flip side, if I'm stretching something vertically, so if I'm pulling it up and stretching it taller, what's happening to its width? It's appearing skinnier, isn't it? And so that's a horizontal shrink, is equivalent to a vertical stretch. And so I'll connect those for you when we get to that lesson in the notes, or that part in the notes. But that is a good connection to make. We tend to, the vertical ones are easier to work with, so we tend to focus on those more. But there are times we have to talk about the horizontal. Okay? Transformations can be performed in succession, one after another. If the transformation involves stretches, shrinks, or reflection, the order in which the transformations are performed may make a difference. So you do have to watch out for order sometimes. Because if you move something, if you move it up and then you try and stretch it, you're working with different values. And so we tend to do our stretches, shrinks, reflections before we do the translations. Okay. Example 1. Describe means we want to use words, yes? And here there's this section should be horizontal and vertical translations. Okay. Describe how the graph of y equals absolute value of x can be transformed to the graph of the given equation. So use words. What's being done to y equals absolute value of x in part A? Okay, so there's a minus 4. So we're subtracting 4, so we're either doing a left-right or an up-down movement. It's not in the absolute value, is it? It's at the end. So that takes me to the verticals. Vertical, you go the direction of the font sign, so we are going to move this graph down 4. What's our good algebra word? Translate. So translate down 4 units, if I want to be good vocabulary there. Okay. And again, it did say to describe based on that y equals absolute value of x. Translate down 4 units, shift down 4 units, move down 4 units. Just do me a favor, don't just say down 4. Put a verb in there, okay? Make it, still not a complete sentence, but at least a complete thought.
6 is down 4 units. Points are going on X.
I don't even know what that
4 units.
Okay. B. Y equals absolute value of x plus 2. What are your thoughts here?
Translating to left
Left
2
2
units.
Okay. The plus 2 is in the absolute value. So that takes us to our left right because it's in there with the x. We're going to go opposite the sign. So we are going to translate left 2 units. Okay? Okay, easy enough. Example 2. They gave us the equation. We had to tell what was happening. Now they're saying, okay, you write the equation based on us telling you what is happening. So we're going to write the equation. When A, we take the graph of y equals x cubed and we shift it down 3 units. What did you say there at the end?
Y equals x cubed minus 3.
Okay.
That's what I got.
What graph do we have to use, or what equation do we have to use? X cubed. Y equals x cubed. Down 3 says you just put minus 3 at the end. So y equals x cubed minus 3. Okay? And, whoops, I don't really have any other way you could express that answer. I think that's probably good there.
Would you put absolute value in there or parentheses?
Not necessary for up and down movement, unless it's already there.
Because it had one up here. So.
On the previous section,
Mhm.
but the previous section, the graph we were working with was absolute value of x. The graph we're working with here is x cubed.
Okay.
So we have a different base graph that we're working with. Okay, B. Same graph, y equals x cubed, except this time, left 2. Thoughts on how to write this?
Put x cubed and plus 2 in parentheses.
Okay, how did you say that, Kylie?
X cubed plus 2 in parentheses.
Like this?
Yes.
I have to disagree.
Dang.
And here's the deal. The reason I have to disagree, I could drop those parentheses off, and it's still equivalent, and x cubed plus 2 would be up to.
Yeah.
So by putting those parentheses around the outside, you're just taking an up to equation and putting parentheses on
I'll try to.
it. Okay? But, and this is what we need to talk about, right? Because she's not the only one that was going to do that.
Me and Emma both
Guaranteed.
did that same negative thing.
Okay.
Did you really?
Exactly.
I think I did the next one wrong too.
Okay, so I need a plan B.
X plus 2 cubed. With the x and plus 2 in parentheses.
Okay, so there's the proper way to do it. And guys, I would have thrown the wrong one up there anyways, okay? I wanted to hear the wrong one because we need to talk about these are different,
Good job speaking up.
okay?
Shut up.
So I needed to hear them both. And again, I know there's more out there that we're doing the wrong one as well. So here's the deal, guys. When you have something like a power or whatever, it scoots over and you're putting that left or right in there with the x. Okay, so obviously the plus 2, no one was questioning the plus 2, the fact that opposite sign is what makes it go left 2, but then you're scooting that cubed power over. Okay, if it was a squared, you'd scoot it over. It just depends on what it is. Are we okay with that?
At least we got the plus 2.
Yeah, hey,
At least
that's
I got that part. It could've
that's
been
half the
worse.
battle.
And the
Okay, as I said, in my opinion, you fell for the common mistake. And, you know, I like to get those common mistakes out there in the open. So, okay, C. Shift the graph. We have a different base graph this time. So we're starting with y equals x minus 1 cubed. And we're going to go right 3 here. So x minus 1 cubed, right 3.
What?
It's okay, Kylie. I'll go.
Floor is yours.
I think
Okay.
it's X
Someone throw
minus-
something at me.
Y equals parentheses x minus 4
Yes, X minus
3
That's what I was
with
getting ready to
the
say.
cubed.
But Sophie said she wanted to.
Three.
Sorry.
Okay. So you said x minus 4.
Parentheses.
With the
Cubed.
Okay. Does this work?
Sure.
Absolutely.
Does it make sense?
Yeah.
Yes.
Okay, let's back up. For those of you saying, why the, wait, a 4. There's no 4 in this problem. Okay. Let's back up and talk about this. So we were given y equals, and it's x minus 1 already. So what is this graph already doing?
Going left
Going right.
1 unit.
Not left one, but
Right.
Right.
right
It's going
one.
right.
Right, okay. It's already going right 1. And then on top of it, we need to go right 3 more. And so we're doing x, you could say minus 3 minus 1 cubed. Or you could have said x minus 1 minus 3 cubed. Either of those are good starting points. The idea that because we're going right 3, we have to put the minus 3 in the parentheses with the x. The x minus 4 is because cleanup, right? Minus 1 minus 3 is going to become minus 4. Okay? It's not that the first two are wrong. It's just those are our beginning steps, and we want to clean it up, though. What?
I did it very wrong.
Okay.
Like a bracket and then parenthesis on the inside.
Yeah,
I don't.
Bracket.
I did X minus
Pause.
3 parenthesis
Yeah.
minus 1 bracket. I don't remember what I did.
Yes.
Bracket.
I mean,
And you could still clean it up, I think. So, okay, say that how you did that.
I have to do it again.
let's take
Like X bracket minus 3. And just in parentheses X minus 1.
Something like that.
And then like, yeah. Well,
Or did you have the pieces?
I think they were switched.
Okay. And here's what I'm gonna say.
Saying
This is equivalent also.
What?
It is equivalent, but you'd have to go farther because
Is it the same?
this x minus 3, listen guys, this x minus 3 doesn't really have anything going on with it. So then I can drop those parentheses and then it becomes x minus 3 minus 1 or x minus 1 minus 3 depending on how you had that. Okay, and then the cubed is still outside, so it still works.
It just looked funny.
Okay, so
It's just not as good look.
ultimately, this is the final answer I want. Okay, so ultimately I want you to get to this final answer.
Wouldn't
Okay.
it multiply by though?
What?
That would like multiply
No.
if it was.
The minus 1? No.
Okay.
No, that
That's
minus 1 is
negative one.
subtracting. But if
oh,
this
but now
goes
on
with
the other side.
this minus 1 is subtracting. If it was multiplying, you'd have to have parentheses or a multiplication symbol or something around it. Now, if it was a positive, just like 1 right there, then I'd be multiplying. But because it's a minus 1, we're not multiplying.
If it was a negative one, it'd have to be on the other side, right?
Or it'd have to have parentheses. Or like if I did that, it's multiplying by negative 1.
Yeah, no.
You're an error.
Or you could put it can go front or back.
Okay, that's what I was trying to do.
But out front, it wouldn't necessarily have to have the parentheses. Out back, it would, because it looks like minus 1. And ironically enough, I had someone come to me first hour working on Algebra 2 problem. And it was that exact issue. They were trying to distribute when they just needed to be subtracting. So,
Like,
okay, focus please.
Focus.
Example 3. Working with reflections here. Find an equation for the reflection of f of x equals 5x minus 9 over x squared plus 3. Now, it doesn't specify what reflection, does it? So we're going to do all 3.
Oh,
Okay?
dang, I really thought
So-
we did a dig.
Let's start by looking at what the reflection across the x-axis looks like. Okay? So start by looking at across the x-axis. If we look at across the x-axis, Mm-hmm.
Can you not
It
just
wasn't
listen
one
to
of
trash?
mine.
I was gonna say I'm dead. Okay, now how do we do a reflection across the x-axis? What's it say up top?
The negative f of x.
Is it negative f of x?
Yeah.
Okay, because so negative f of x says I multiply the equation by a
Negative.
negative. Now, in this case, it's a little different. My equation is a fraction, right? If my equation is just individual terms added and subtracted, we multiply each term by a negative. Now, with a fraction, there's a couple different ways we can do it. One, we can put the negative out front of the fraction bar and say is negative of 5x minus 9 over x squared plus 3. So that's one option, is to just put the negative out front of the fraction. Now, when you do that, though, it's not in front of the 5x. It's not in front of the x squared. It is in front of the fraction bar. Okay? Now, and I'm going to put parentheses around that fraction bar.
That's what I did.
Now, how to actually multiply that negative in? What is negative 1 as a fraction? Negative 1 over positive 1, yes? So do both top and bottom get multiplied by a negative?
No.
No, just one of them. And so this is where you can pick. I mean, I tend to multiply the top by a negative, but you can officially pick which way you want to go with that. But I can take this negative and distribute it in to either the numerator or the denominator. And when I do that, on top it's going to become negative 5x plus 9 over your still x squared plus 3 in the denominator. And that would be a reflection across the x-axis. Okay. Now let's try reflection across the y-axis. Okay, what is the reflection across the y-axis rule? Okay, f of negative x. Every place I see an x, we're going to replace it with negative x. Got it? You know that phrase is coming out of my mouth, right? Every place you see an x, replace with negative x. So, on top, it's 5x minus 9. So I'm going to say instead of 5 times x, 5 times negative x minus 9. I'll clean this up here in a moment. On bottom, it's x squared plus 3. Instead of x to the second, I'm going to say negative x to the second plus 3. So, on top, what is 5 times negative x? Negative 5x, so I have negative 5x minus 9 over, what is negative x quantity squared?
X.
Positive x squared plus 3. So my reflection across the y-axis is negative 5x minus 9 over x squared plus 3. Now, if you really wanted to, could you graphically check these? Check yourself?
If you could.
Okay.
I'm not gonna lie, I love doing these.
Okay.
They're so fun to me.
And here's the deal. You would do that by, you could type in the original equation, right? You could type in your across the x-axis. You could compare them. Yes.
Kind of like solving a puzzle.
Yes. Mm-hmm. Nope, you're fine.
They're so
Okay. And last one. Across the origin. Across the origin is negative f of negative x. So we're doing both of the two things we just did at the same time. So I'm going to put a negative out front. And I'm going to use parentheses on this one. And then every place I see an X, we're going to put a negative X, right? So this is what we did earlier. We said 5 times negative X minus 9 over negative X to the second plus 3. Now that's me kind of showing my work there. But really the inside of that is going to be what we just had for across the y-axis, right? So the inside of that is going to be, I'm going to leave my negative outside again. Negative 5x minus 9 over the positive x squared plus 3. Then how do I deal with that negative out front? We can distribute. And so when I distribute this, negative times negative is going to be positive 5x, now plus 9, still over x squared plus 3. And that is negative f of negative x.
You could give us a whole test of these, and I wouldn't be sad. I love doing these so much.
Okay. Now,
These are my
again,
favorite things.
you guys can put these in the calculator to kind of test them and see where you end up at.
My favorite thing is factoring. If you had a whole test about factoring,
See,
I'm
I'm
so
so
happy.
factoring
No,
too.
no,
Okay. Let's see. If you flip over to the back side, we'll have to save this for the most part tomorrow. But on the back side, we're talking about our stretches and strengths. And it says state the horizontal stretch or strength, but I'm going to make that horizontal or vertical because I want to talk about both. Okay. I want to talk about both. Something like A is more obvious. Something like B and C, a little bit more difficult, a little more challenging. Okay. Okay, so we will pick up there on Monday. We'll do the back side of the notes on Monday. Homework is page 131, 2 through 32 evens, and that will be due on Tuesday.